right, y'all, we are on Module 6. We're going to be looking at the skeletal muscle system today. We're going to have a video in a second to review all the muscle types in a second, but we're going to just have an introduction here of skeletal. Then we'll spend the rest of the time on skeletal muscle. Okay, so good news is there's nothing really difficult in this module unless you have a serious problem with memorizing. There's lots of memorizing, okay? And that's really, you're going to be memorizing some of the muscles. Like you memorize some of the bones, right? So now we're going to look at some of the muscles and memorize those. Okay, so skeletal muscles attached to bones by way of a tendon. We can see here the muscle where it's very red right there. That's got a lot of blood supply, highly vascular. And then notice it turns white here at the top and the bottom. That's because the muscle actually turns from muscular tissue. Remember, that's one of the types of tissue. And we know about muscular tissue, it's highly vascular. It's also innervated. In other words, it can be moved by energy, right? We saw that last module, the sarcomeres contracting and that kind of thing. All right, but when it turns into connective tissue, that white tissue right there, it's white because it's not very vascular, and it's very, very strong. And it's connective tissue, therefore it's connecting the muscle to the bone. All right, so remember bone-to-bone connection, that's called a ligament. Muscle to bone is called a tendon. I don't believe there's a place to write that down, but I do want you to remember that, the difference between a ligament and a tendon. So the way you can remember ligament is in the knees, ACL, anterior cruciate ligament. Question, you voted? Oh, I was about to say.
Future.
Oh, future vote. Okay, I was about to say, are you 18? That would be awesome if you were. All right, we're going to look in more detail at the muscle here in just a minute. There are about 640 skeletal muscles. The good news is you do not need to know all 640 muscles, okay? But you do need to know some. And so today we're going to spend a lot of time going through names of muscles. Bad news is the names are all over the place. There's no real system to naming muscles. There's some named by tradition, and we're going to get into how they're named here in just a second. All right, so I believe you're going to have some blanks to fill in here. Muscle attached to bone by tendon past the joint. The one bone that's moving, so we're going to be looking at moving. The idea is muscles move our bones. So the one that's doing the moving, that tendon is attached to the bone. That part that's attached to the moving part is called the insertion. So do you have the word insertion there? Insertion is going to be the tendon that attaches on the moving bone. The tendon that attaches on the moving bone. Therefore, the bone that's not moving, so in this case I'm doing my arm like this. Right, so here the bone that's not moving, this bone, that means the more stationary bone is going to have what's known as the origin or the head of the muscle. All right, so you're going to say origin would be on the more stationary bone, the bone that doesn't move as much. Because remember, the muscles are moving our bones. All right, the largest part of the muscle is known as the belly of the muscle. So belly is the largest portion. So when we draw it, we kind of draw it skinny on the ends and fat in the middle. Muscles kind of like this. That's the belly, right in there. And then, of course, we're going to have tendon at top and bottom that's going to attach to a bone. And remember, the bone it's attaching to is actually beyond the joint. So it attaches beyond the joint. That's what gives it the power. We're going to see how the muscles act, make the bone act like a lever. So they get leverage. All right. In the limbs, arms and legs, the origins are more proximal. Do you remember what proximal means? We learned our little anatomical words. Remember proximity? Those are the ones closer in. And the origins are more proximal. The insertions are more distal. That's the easy one. Distal, distant. Okay, so remember that? The more distant ones. And then in the trunk, the origins are more medial, toward the middle, and the insertions are more lateral, toward the sides. Just talking about what bone they're attached to. Okay, it gets a little complex there. I'm not as concerned about the origins and insertions, as long as you know they're different, okay? One's on the moving bone, one's on the non-moving bone. I'm not gonna say on this muscle, where is the insertion? I'm not gonna ask you that. Medical school, you'll get that. Okay, this isn't medical school. All right, let's take a look at it here. We've got a muscle here. We're looking at the arm, the upper arm. The muscle right here, what do y'all know what it's called? Yes? Tricep. I really have one, can't really see it. It's called the biceps, but we have to remember it's called the biceps brachii, because brachii means arm. There's another biceps in our body, but it's not on our arms. So to be real specific, we typically just call it the biceps. On the other side is the triceps, okay, which we'll get to. All right, so we can see here the tendons at the top. Here's the belly of the biceps muscle. And then the tendon, notice how it's going beyond the joint there. And up here it's going beyond that joint. Do you see that? So notice how with that tendon being attached below my elbow, when I contract that muscle, do you see how it pulls that part of my arm up? That's pretty cool, right? That's how it does it. It attains leverage there. Okay, so we're going to talk in a minute about that biceps and why it's called a biceps and why this is called a triceps. One of them has 2 something, the other one has 3 something, right? So it's one of our ways of naming things. Okay, the word synergy or synergists is an important word. Muscles never work alone. They're always working at least in pairs, When I contract my biceps brachii, my triceps brachii must relax. When I go this way, my biceps must relax, so my triceps can contract, okay? The chief moving muscle, here my biceps, curling my arm, is called the prime mover. That's the thing that's moving. And the one that's relaxing on the other side is called the antagonist. Anybody into literature? We have protagonist would be our hero, and our antagonist would be our anti-hero or our villain. Also, did you know in a lot of the ancient, maybe not ancient literature, in early Christian literature, prime mover almost always refers to God. He's the prime mover of all things. If you've ever read like Scarlet Letter or something like that, they call him the prime mover. And then the antagonist would be the devil, right? So God, the devil, that kind of thing. When the prime mover contracts, the antagonist will relax, passively stretching. It'll passively stretch. It's called synergy. These are called synergists. Okay, muscles pull, they do not push. Once again, we are looking at our biceps right here. And our tendons, notice it says tendons on the top, or an S right there, 2 tendons, because at the top of the biceps muscle, it actually divides into 2, so it's one muscle, divides into 2, and has 2 tendons, biceps. That's why it's called that. All right, and so we know it has 2 heads. Sometimes when you have a prefix like that, it's referring to the number of heads on it. Sometimes it's referring to the numbers of muscles, actually. So we'll get to that in a minute. Here is the triceps. We're looking at the back of the arm now. So the triceps has 3 different sides. So here's the triceps brachii, lateral side, the longus, the medius. Medius, lateral, longus. It's one muscle with 3 heads right here. But this is a large tendon coming down right down here, down to the bottom, right there. So we have the medius. Notice the medius is swirling all the way down to here. We have the longus. What do you think longus means? Long, yeah. See, so some of the words aren't too bad. If you remember, lateral means to the side. Medius, middle. Yeah, so that's going to be that. We're going to see words like that that give us some hints as to where in the world that muscle is found. Is it raining?
Yeah, it's drizzling.
Is it drizzling? Okay. All right, so here we can see the contraction of the biceps, the relaxation of the triceps. And now the other way, contraction on triceps, contraction on biceps. Contraction on the triceps. I don't know about y'all, but our triceps, my triceps is pretty pitiful. You know, to do an exercise to strengthen your triceps, you need to hold your weights up like this and go this way.
Skull crusher.
What's it called?
Skull crusher.
This is called skull crusher?
I think so.
Sometimes I have trouble doing it, so I can do it this way backwards like this with a weight. Okay, this is easy to curl, right? That curl's easy to do. It's the other one that, to try to develop that muscle, is a little more difficult. All right, you're supposed to write down the levers. We have first, second, and third class levers in our bodies, and I'm going to tell you that in your book it talks about the first class lever being something to do in our arms, but do this one instead. Write down your neck, okay? Because right here, when we have, a lever has a fulcrum and then it has movement along the fulcrum. One of them we call the load or the lift, we're lifting something. The other one we call the effort, we're squeezing something. So on the scissors right here, our effort is squeezing the scissors, the fulcrum in the middle, and the load would be in between. So if you do your head back and forth like this, up and down, that's like a first class lever. I've got the fulcrum in the middle. I've always found these levers in the body to be a little confusing. Just know that all three lever classes are present in our muscular system of our bodies. The second class lever, like a wheelbarrow, we have that when we stand on our tippy toes. All right, so say that our fulcrum is at the tip, in this case the tip of our toes. Like this, we have something lifting. It's going to be these muscles in our calf muscles. We're going to get to those, they have a funny name. And then we can lift ourselves up. Here we're back to our biceps brachii here on the third class lever, where our fulcrum is the elbow. That might be the easiest one to say. I'm lifting something with my hand, therefore the effort is up in my biceps to lift something. I'm curling here. Okay, so my fulcrum's in that elbow. It's easy to see a fulcrum in the elbow, like a pair of tongs or tweezers or something. First class lever, second class lever, third class lever. So your neck would be your first class. You're standing on your tippy toes, contracting your biceps, moving your arm in. We're going to also look at those words adduction and abduction. Remember adduction, abduction. We learned that in a couple of modules ago. All right, so we have something written down in each one of the types of levers there. What I want the takeaway for me is that our muscles act like levers and give us more strength. It gives you leverage, right? It gives you more strength. All right, here comes the tough part of the module. It's just naming them, and essentially some of them you can figure out, but some of them you're just gonna have to memorize. Sometimes, like we had to memorize some of the bones, right? Okay, muscle names are complex. They might be named by, I think we're gonna write a couple of these down, their size. Like gluteus maximus, size. Shape. Our deltoid is shaped like a triangle. We'll get to that one. Location. Biceps brachii. Brachii means it's in the arm. The fascicle lines, the way the lines are running. We have some called the obliques, and it has to do with the way that the lines are running kind of not parallel. They're running at an angle. Origin and insertion, sometimes based on where the origin and insertion are of those. Remember, those are how they enter into the bone. The number of heads, biceps, triceps. The function, let me think of one of those for function. Orbicularis oculi, that's one of them. We'll get to that. Wow, we need to know several of the muscles. The coloring book would be helpful here. How y'all doing on coloring book? Y'all keeping up with that?
Yeah, there's a problem with the coloring book. I think our textbooks want a newer edition of the book.
I think the coloring book's a newer edition, right?
Because some of the coloring examples, they say only do like A, B, and C.
Mm-hmm.
But then ours has like a bunch of them. But yeah, the book isn't always consistent with the coloring material.
Okay, but is it the right page? I thought maybe the
Pretty sure.
pages might be messed up.
Pretty sure the pages are
Pages are
right
alright?
for the most part.
Okay.
For the most part.
So whatever you turn in on the coloring book, you'll get extra credit for that. All right, so we're gonna do a quick reminder on some of our muscles and then talk about naming some of them on a review right here.
Three types of muscles are contained within the human body: smooth, cardiac, and skeletal muscles. Smooth muscles are found in the walls of many organs, such as the stomach and in blood vessels. They have a non-striated appearance and contract involuntarily. Cardiac muscles are found in the walls of the heart. They also contract involuntarily but have a striated appearance. Skeletal muscles are attached to and move bones. These muscles contract voluntarily and have a striated appearance. Skeletal muscles are subcategorized into 4 distinct groups based on the orientation and arrangement of their muscle fibers. Parallel skeletal muscles consist of fibers that are arranged in parallel to the line of pull during contraction. Parallel muscles can be subcategorized based on their shape into quadrilateral, strap-like, and fusiform. Convergent muscles contain fibers that have a wide origin, but converge in order to attach to a narrow tendon. Circular skeletal muscles are made up of fibers that are arranged in a circular manner. They are found at points of openings where the contraction leads to a closure of that opening. Innate skeletal muscles consist of muscle fibers that are attached to the sides of a tendon in a manner that is similar to a feather. Pinnate muscles can be subcategorized based on their shape into unipinnate muscles, bipinnate, and multipinnate.
All right, looks like that's all we're gonna watch on that one. Okay, so if we're gonna look at the body right here, we're gonna go through each one of these systems, but you can see here from the front view and then from the rear view, we're gonna see all these different kind of muscles here. Now, keep in mind when we talk about the belly of the muscle, and say, so we're looking here at our picture of our biceps right here, that muscle is one muscle, and it's contained in a membrane. Okay, that's kind of keeping its shape that way. We're going to find this next week for our lab. We're going to actually dissect muscle groups. Okay, so we're going to see how those groups come apart as these little chunks. You already kind of know this. For instance, if you've gone to the chicken joint, you know, the fried chicken place, and you get the tenders, all right, you know, that's a complete muscle that you're getting, and it's a very tender muscle. We'll look at that in a second. That's why they're called tenders, right? In beef, it's called the tenderloin. It's one of the best cuts of beef. All right, but back to our human deal. We're going to be looking at several of these different muscles, front and back. We're going to key in on the face, upper body, abdomen, legs, feet, hands. Okay? All right, so let's start with facial. The facial muscles. It turns out humans have a wide variety of facial expressions, right? We can do all sorts of facial expressions. And it has to do with the extreme muscularization of our faces. Now, what's interesting about the muscles in our face, they're not too bulky, right? We don't have giant bulges in our face because we have smaller muscles that have larger motor units coming to them to give us a little more finesse in these. All right, so we're going to start with the sternocleidomastoid. Sternocleidomastoid. Well, the next slide that I show you will show that better. It's coming along the neck. You can't really see it. This is it right here on the neck. I will show you a better picture of this. The reason why they include this in the face is because this is what turns your head. You can, if you bend your head to one side, you can feel it stretching. You can feel it stretching the other side. It's a long muscle that comes all the way down to your sternum. Remember what is the sternum? Breastplate, right? And then cleido means clavicle. So it's attaching to the sternum and the clavicle, and the mastoid is up here in your skull. All right, we'll get to that next slide, like I said. Okay, the occipital frontalis. Now, what do we know about occipital? What can you remember about the occipital? We talked about the occipital bone. Where is the occipital bone? It's in the back of your skull, right here. Remember, it's covering we're going to find this out later, it's covering the occipital lobe of your brain. The occipital lobe of your brain is responsible for your vision. So our vision is received and interpreted by the very back of our brain. And this bone is covering it. So this muscle goes from the back of the head to the forehead. And they work together. We put them together because they're always working together. So if you raise your eyebrows up, you can feel it pulling up this way and pulling down that way. If you put your eyebrows down,
Is that why, like, when you fall and hit the back of your head, that kind of
that's why you see stars. That's the only way it knows how to react. That's exactly why you do that. All right, so occipital frontalis is going to be our eyebrows up, our eyebrows down. You can kind of feel it. Okay, and notice the way the fascicles are running like this. So when we pull that up, In order to pull that up, what happens to our skin above it, it kind of, like you're pulling up blinds, right? It pulls it up. That's why the lines of wrinkles on your forehead go this way, go horizontally, because you're pulling those muscles up vertically, like blinds. All right, you end up, and if you do it a lot, like older people, like me, for instance, you might have some lines in your forehead right there. Okay, the orbicularis oculi. Okay, what you need to know about orbicularis, that's going to be circle. Oculi is the eye. All right, so this is the muscle, a circular muscle around your eye. This is the muscle responsible for winking. So if you wink, you can feel it go, just kind of closes up like that. Interestingly, we're going to see another one in a minute. There's a circular muscle in our eyeball as well. Right there, that colored part, the iris of your eye has a circular muscle that closes up and opens up, allowing less or more light in. Pretty cool. The orbicularis, that means it's round. Oris, what's your guess? Oris.
Your nose.
Oral.
Oh, oral.
Your mouth. Okay, so can y'all whistle? That's you're bringing that muscle in like that. Okay, you're tightening that round muscle. It's interesting in your book, it mentioned that people who purse their lips a lot might end up with the wrinkles right here on top of your lip. And they mentioned like smokers. Because smokers are going to purse their lips a lot, right? Furthermore, the smoke kind of clogs up all those little tiny capillaries in your skin.
And it makes wrinkles?
It makes wrinkles, yeah. So the more you use them, like for instance, if you know somebody who is like happy all the time, they might have a smile wrinkle, right here, because they're smiling, you know. And that's a prettier wrinkle than a Yeah, right. You want it to have wrinkles here. So the orbicularis oris is right here, and then this one, right along here, on the cheek, is the buccinator. So the orbicularis oris and the buccinator working together are known as the kissing muscles. That purses the lips. You can feel them drawing from the cheek, and then of course that circular muscle around the lips. So we have our winking muscle and our kissing muscles. Okay? Remember, all sorts of facial expressions. Our zygomaticus major and our zygomaticus minor, they're right here. They're kind of small. Those are gonna pull up the lip and pull up the cheeks. Those are your smiling muscles. Our zygomaticus, major and minor. So if you think, what do you think the difference is between major and minor?
One's a minor and one's a major.
What does that mean?
That it's not as, I guess. Not used as much.
It's actually referring to the size.
Interesting.
So major's going to be bigger, and minor's going to be smaller. But I think they're just as important. Then we're going to see here the levitator labii. Is that next? No, the platysma. The platysma is this big muscle right here. And it's interesting. This giant muscle right here comes and it actually attaches down to your chest and sternum. It comes all the way down. That's the muscle you need for frowning. So you need a lot more muscle tissue to frown. So have you ever heard that expression? It takes fewer muscles to smile than it does to frown. It's true. Muscle tissue. The platysma is one muscle. The zygomaticus, there's two different muscles there. Plus we have the levitator labii. Do I not have that one? Oh, the masseter. Okay, the levitator labii. Think of that. Labii, lips. Levitator, lifting. You're going to do the Elvis with your lip. You know, he does this little lip thing. That's your levitator labii that's doing that. Or you can say, ooh, pull that lip up. The masseter is, do you see it on here? Right here. It's a very strong muscle. Right in here, we use that for speaking, moving our jaw, for chewing. Y'all ever chew gum? Do you ever get to the point where it makes your jaw sore? When you get to I can't chew gum anymore. It makes my jaw sore. So, and my masseter just gets worn out right there. So that's the masseter right there. All right, so those are the ones I'm interested in. And if I'm interested in it, y'all need to be interested in it, okay? There will be more muscles listed in your book. I'm not interested in those. Just these. Okay, here's our sternocleidomastoid right here. It's going all the way up here. This is the where it's inserting into the skull right here, and then coming down here to the clavicle and to the sternum. Where's it say sternal head right here? Where's the clavicle? It's supposed to be coming into the clavicle as well. I don't know if you can see it very well. But that's the muscle that's really connecting your head to your body. If you want to move your neck back and forth, you move your neck completely backward. That sternocleidomastoid is really stretching. Then your chin to your chest, sternocleidomastoid. You can feel it stretching in the back against the levitator. Look at that. Levator scapulae. What's happening there? What's the levator scapulae doing?
Is that holding your head up?
Lifting the scapula. It's the bone. It's lifting that, okay? Scalene muscles, that talks about the way their fascicles are. We have anterior, middle, posterior right in there. We're going to get to these other ones right here. Okay, masseter, look how big it is. That's our chewing. We'll talk about that some more as well. All right, so that's what we have for face. You have several of those written down for face. Show muscles, yes.
Why can you only do, some people can only do one thing on one side of their face? Some people can only move with one eye or
I don't know.
move their lip one way and one. but they
Right,
can't
so
do it
it's
on
kind
the
of
other
like
side.
being left-handed and right-handed, I think. You know, so there's just they're more used to. I think muscle memory is probably the better explanation versus inability. Then there's of course stroke victims which they don't have access to half their bodies, so it could be something like that. Hopefully not. All right, chest and abdomen. What do I want you to know about the chest and the abdomen? We got lots and lots of muscles here. We don't have to know them all. Deltoid. The deltoid is on the shoulder right here, and if you look at it from the side, which we will see in a minute, it comes down and it's shaped like a triangle. That's why it's called deltoid, because that's the letter delta, the Greek letter delta is a triangle. So the deltoid muscle. The pectoralis major, you've heard of this, your pecs, right here. The chest muscles right here, this is major being the big ones because we have smaller ones underneath called the pectoralis minor. Those are right under here. Notice how those are connecting to the rib cage. It turns out when you take a big inhalation, you're going to use those pectoralis minor to open up your chest bigger. When we get to the respiration part that we're learning about in Module 14, we'll learn all about those muscles that help us respire, help us to breathe. Okay, so our pectoralis major right here, we're going to use that as, so if you put your hands in front of you like you're sleepwalking, those pecs are now contracting like this, and if you move them out to the side right there, you can feel those contracting to this side, okay? So we're looking at maybe swimming would be good for developing our pecs, right? Pulling our arms forward and like that. And you can maybe look at a swimmer's body and see how they have, the guys have large pecs. Rectus abdominis, okay, so the abdominis, abdomen, right? That's the abdomen. Rectus just means straight. And so what we have in there is, we notice how those little muscle fascicles are running very, very up and down. Parallel lines, straight, straight, straight. So and they're covered with this white stuff right here, which is called a sheath. It's connective tissue that's holding those in place. And if you are young, you probably can see how those little abdominis muscles are compacted into what we call the six-pack, right? I don't possess that personally. Guys have a better chance of developing a six-pack, and you do that by contracting those with sit-ups and whatever other muscular exercise you can do for that. But they're straight. The white part here is not muscle tissue, it's connective tissue, but it's like a sheath holding them in place. The internal oblique. So oblique means that the fascicles are running at an angle to the rest of the body. Let's see if we can find those. Here's our external obliques. Where's our internal? Internal abdominal oblique right here, cut away. They had to cut away some of this stuff here in order to see those. So we have our rectus abdominis going this way, and so these are going up and down, and across the top of them, these muscles come in at an angle. That's going to give your abdomen a whole lot of power. Okay, so you have a lot of muscular ability in those muscles. We have our external obliques right here coming at the other, so one angle this way, the other angle this way, giving you much more strength. And then our transverse going all the way across, abdominis. So those you see abdominis should help you know we're in the abdomen right there. So what are the big ones here? I'm going to say our pecs, our deltoid. Look, there's that platysma, the frowning muscle. Look at it up there. See how it's connected down here past the clavicle, down into the sternum as well. That's that big one for frowning. Okay. How are we feeling? Are you getting a headache or falling asleep or?
Too many muscles.
Too many muscles. At least we're not having to learn all 640. In nursing school you will. In medical school you will. In physical therapy school you'll need to know more. So, okay, the back muscles. Look at those. Look, you can see the deltoid really nicely. See that triangle? Very nice. It's kind of coming over the top of your shoulder this way. If you put your arms, like, lift them that way, you can see it. The trapezius. Okay, this large muscle in the back is called the it's supposed to be trapezoid shaped. What would y'all consider to be trapezoid shaped? Here, it looks almost like a big triangle coming this way, and it goes this side too. So it's kind of like two.
And it looks kind of like a triangle. It looks more like a triangle.
Almost like a diamond shape, if you ask me, like two triangles. Right there. Okay, so with the trapezius right here, we're going to see, I'm have a little, like a animation that shows you. So if you say, if I ask you, what's the name of that big muscle in your back, you say, I don't know. That's your trapezius lifting your, I don't know, that's the shrug. The shrug, that's my trapezius doing that. And then if I go backward like that, we'll see it in a second. The latissimus dorsi. First of all, dorsi, that means your back. Dorsal, okay, latissimus means your side. So where's that muscle? Side back. Side back, right here. Sometimes we call those the lats. The lats. Okay. This is the muscle, like, has anybody ever been rowing? This is the muscle you're going to take to row a boat like this. Okay, I don't want to tell you, have you ever watched men's gymnastics? Okay,
Yes.
there is a element in the men's gymnastics that the women don't do, because we can't.
So when they like do that spinny thing?
No, it's the rings.
Yeah.
The ring?
So there's straps holding a ring. There's
Oh.
nothing.
Oh.
And
We
you're,
haven't seen
these
it.
guys
Yeah.
can put themselves between the rings like this
Oh yeah.
and hold themselves straight out like this. And if you watch really closely, you can see them. Because all those, those lats are really working. Notice next time, if you ever see a guy who's been doing that, a guy in gymnastics, his back sort of almost bows out like this right here. Those are his latissimus dorsi. He really, and so he can do this, you know, I think this would probably be easier to do this, but he goes out like, that's what really fascinates me, when they go out to the side like this, and then they flip and all this kind of crazy stuff. Women don't have that sport.
They don't have the strength to do it with their body.
We don't have the type of development in the latissimus dorsi. We don't have that. Same in the upper body strength. The women just don't have the same. Women's muscular system is concentrated on the hips, because women have to give birth to babies. That's
Yeah,
why.
we have Karate also.
Yeah, we create like there. Yeah. All right, so those are our lats. Remember, rowing or the guys on the rings.
You're talking like you
Rhomboideus major. So once again, we have a shape, rhomboid shape. I'm not exactly sure what a rhomboid looks like, but our rhomboideus major, right underneath our trapezius, and we can guess we're going to have our minor, which is the smaller one, right under it, right there. Major's kind of covering over the top of the smaller one right there. Okay, so when I bring all my gear to class, I have to load stuff up into my car, and it usually is my trapezius that I end up hurting. And so it's just, you know, my shoulders and my back right there that I end up hurting. So I've got to do exercises to keep my trapezius in shape. All right, here's our levator scapulae. We talked about that earlier. What's our levator scapulae going to do? It's going to lift my
Lift your
scapula. Okay, so I'm going to take my trapezius, my levator scapulae, and I'm going to lift my scapulae up. Remember, scapula is just plural for scapula. Scapula. So sometimes I might ask you something, and you might have a hint, like dorsi. Oh, it's in the back somewhere. It's in the back somewhere. Some of these you're just going to have to remember. All right, so we have a few of these written down. All right, here I'm going to look at it a little more closely. Here we go. Here's our deltoid in the green.
See right there, the blue one, that does look like a trapeze.
That's the trapezius right there, and it goes on the other side as well. Okay, look, we're looking at somebody who's quite developed in their muscular system. And then we have we're going to look at our teres major and teres minor here. Here's our latissimus dorsi to the side right there. Notice the way that the muscle fascicles are moving. They're going like across each other here to give more strength to this area. So let's take a look. I'm just fascinated with the trapezius because I injure mine frequently. So here, I'm going to use that. If I did the shrug, then I'm using that lower part of the trapezius, and then I have to relax it. And then if I pull them in back like this, I'm going to use the upper part of the trapezius and pull my scapula in like that. So that's once again maybe our rowing would be used there. Okay, which brings us to our teres major. I want to talk about the teres major real quick. Okay, it's in our back, and that's a complete muscle, right? This is not a human muscle. That's a cow muscle right there. But I've been to restaurants before where they say, oh, our steak selection tonight we have teres major. I said, what? You have teres major? Because it's like the same name as our muscle, right? It's the bigger one of those ones underneath the trapezius. Okay, so if we're looking at a cow, it's going to be right in the back, right here, and we're going to find it right. You see, it says it right here. You can see it's right there. The teres major, right in there. So, but if we go back one right here, look here. Look at this right here, called the tenderloin. You ever had filet mignon? That's the tenderloin. And they're known for being very, very tender. Now, the reason they're tender is that the cow is walking on 4 legs. And this part of his back right here, the tenderloin area right here, is barely used at all by the cow. So that's why the muscle's so nice and tender. It doesn't have a whole lot of work being done. Whereas the work down here, like look at the front right there. What do we know about brisket? That's good, yeah, but you got to cook the heck out of it, right? Otherwise, it's going to be, if you don't cook it right, it's stringy and gross. You got to smoke it, and at the restaurants they smoke it like overnight, right, for hours and hours and hours to tenderize it. You got to tenderize that meat because it's being used more. The foreshank as well, and you can see, yeah, ribs, beef ribs, good stuff. These are the different cuts that come from a cow. So keep in mind, we're talking about muscles here.
No, really.
That's what we eat when we're eating steak. We're eating the cow's muscles. All right, this one you need to put a star by. Okay, these are the muscles that are keeping the shoulder. Remember we talked about what kind of joints in the shoulder? Ball and socket, which has really good motion, but what's the downfall?
It can pop out.
Yeah, it can pop out. It's not very secure. So guess what? I've got a ton of muscles that are keeping it in place. And the name of those muscles are called the rotator cuff. You've probably heard of it. If somebody has a rotator cuff injury, it's an injury in their muscle, not in their bone, in their muscle. Okay, it turns out there are 4, and I want you to know all 4 of these.
Is that the shoulder? What is that?
Shoulder. Yeah, so we're looking at the front of the shoulder here and the back of the shoulder here because you can't see one of these muscles very well from the front. This one actually is going under the scapula. So what are the 4 muscles? Now, number 1, the supraspinatus. Supraspinatus is, it's inserting over here at the top of the humerus, and it's coming right here across. Here's the top of the humerus coming across. What's it connected to? The very end, which is connected over here to the spine. So it's above where it's connected to the spine. Supraspinatus. The infraspinatus is underneath here. We can't see it from the front view. The back view. We can only see it from the front view. Okay, and it's going to be infraspinatus, so it's going to be inside the other one, inside directionally, not physically. The teres minor, right here underneath the large infraspinatus. Oh, look, you can see that infraspinatus. That's the big one in the front here. I was looking at that incorrectly, sorry. I was looking for the subscapular. Under the scapula. So if you know somebody, like I have a friend who is a UPS driver, and so therefore he's lifting lots of boxes every day, heavy boxes. After some time, he ended up pretty much permanently scarring his tissue in his rotator cuff. And it's muscle. It usually separates between the muscle and the tendon, and therefore sometimes it can be a little difficult to fix it. A lot of times rest will do the job right there. If the tear's in the muscle, just in the muscle, that'll heal okay, because guess what? I have lots of blood flow there. But if the tear goes into the tendon, not a lot of blood flow there. It's going to take longer for a tendon injury to heal up. So they may have a tear in one of the muscles, all of the muscles. For instance, if you put your hands against the wall like this, your back should just kind of be flat. Well, his back pops out. His little scapula pop out like this because I believe it's his infraspinatus is not very strong because it's torn. Therefore, he had trouble lifting boxes and things like that. I think he's about to retire from UPS. Okay, so we understand the rotator cuff? Memorize those. All right. Here we're looking at the upper arm. Once again, deltoid, kind of see that triangle thing going there. Here's our biceps brachii. This one, the brachialis and the brachioradialis. So brachii means arm. Okay, brachio, what do you think radialis means? What bone is down here? The radius. So it's going from the arm down to connecting to the radius. That's where its insertion origin goes. We're going to see here our extensor carpi. Where are the carpal bones? Right here. That's going to come all the way down. Look, radialis longus. It's going to come all the way from here, all the way down to our carpal bones down here. Okay? We're going to find interesting about our hands here in just a minute. Okay, so that's winding up. That's a what do you call that? A summary of the first part. Now we're going to 6B. So open your pages now to 6B. Are we there? It says 38. Is that correct? Page 38?
It's 46.
46. That's from the old book, apparently. Okay, the process of mastication is the process of chewing. That's your top blank right there. What is mastication? Chewing. And we're going to use muscles for that. You're going to see right here, there's our masseter muscle we've already talked about. That's this big one. The one that for me gets sore when I chew gum. All right? But also we have this temporalis muscle. You ever seen people, maybe if you know anybody who's bald, and they're chewing, you can actually see it moving right up in here, right? Yeah, that's because that muscle is also involved. You can feel it. Moving right there. Yeah. Okay. It's involved in the chewing process. Not how big it is. Wow. Okay. And remember that our jawbone right here, we have our masseter and then our, what's our bottom jaw called?
Is the temporalis the one that you can move your ear?
I think so. Yeah, people who can move their ears. Can you do it? Okay, I can't do it.
I can do it.
Yeah, you can move your ears. Pretty cool. That's that masseter, that temporalis muscle. Temporalis being the temporal bone of the skull, right? Some people can make their whole hairline go up and down, you know. And here's our masseter and our buccinator. That's part of, because when we're chewing, we're going to also pull our lips together somewhere like this. So here we're going to see, notice how that one's moving, that one's moving. And I don't think that's supposed to be the buccinator there. But you can see how that's going to help our jaw move. The mandible, the lower jaw is called the mandible. Remember, it's not connected. It's just connected. There's a little joint there. It's called the temporomandibular joint. If you've ever noticed a problem that pops out like that, and it can cause a problem, cause headaches and things like this for people who have that joint right there. It can get messed up. All right, miraculous hands. I find our hands to be an amazing piece of engineering that God has provided us with. Let's see why. Oh, there we go. We can do all sorts of things with our hands. We can make this kind of signal. Some people don't want to do that. They won this weekend, which I never would have predicted that. They beat Kansas or whoever. Yeah. So you can see right here our muscles in our hand. We're going to see that our hand actually is controlled not just by muscles in the hand, but muscles in our arm and even in our upper arm are going to help control our hands right here. All right, so we call the extrinsic hand muscles the muscles controlling our hand, but they're not in our hand. Now, what this does for us, y'all, is we can have some strong hands. Our hands can be very strong without being very bulky. We don't have a lot of bulky musculature on our hands. So the muscles in the forearm, which create motion in the hands, the intrinsic are the muscles that are actually in the hands, which we'll get to in a second. So some of the ones that are extrinsic would be, look at here, extensor carpi radialis longus. Remember? We saw that in the last one. It starts up here, comes all the way down. It's long. It's going to connect. Notice how it looks. All these muscles are red here. Notice by the time they get down to the wrist, they're not red anymore. What are they? They're tendons. Okay, so put your hand in front of you and go like this. Like, bring your palm way open. Do you see these things right here? You can push on those. Those are not bones. Those are those tendons coming in from these muscles up here. And it's causing that to give me some power from these extrinsic hand muscles. Now the intrinsic, like I said, is inside the hand. So what else do we have? The extensor carpi radialis brevis brief, shorter. It's the shorter one. The flexor carpi, I'm going to flex my fingers. My wrist, flex my wrist. Do this to my wrist. I'm going to sit back on my hands like this, okay? Palmaris longus is where to come down and deal with our palm all the way down. Our flexor carpi ulnaris, what's that bone it connected to? The ulna versus the radius, see? So if you see that, you see ulna, oh, that's in the arm somewhere. That's somewhere in the lower part of the arm. And then our flexor digitorum superficialis. Superficialis means it's going to be higher up, not deeper down. All right, so a few of those. Mostly what I want you to know about this slide, extrinsic, controlling our hands from another place. It gives us like cable control. Gives us all that power without all that bulk. Okay, that's what I mostly want you to know. Then we're going to look at, these are the ones I want you to especially know. Okay, remember pronation and supination. Remember this? Pronation, you're sleepwalking like this. Supination, you're making a bowl of soup. Yes? Okay, the muscles that are doing that are, one of them is called the pronator teres. Okay, what is pronate? It's going to make, pronator teres is going to allow me to do that, yes? But I also have one called the supinator. What's it going to do? Supinate, like this. But I have to have my synergists working here. So I also have a pronator quadratus. What do you think quadratus means? Is it in there? It's got 4 parts to it. It's got 4 look, it's not very large. You see it right here. Quadratus. It's got 4 parts to it that are, look what it's turning right there. It's turning my wrist between my radius and ulna to pronate, supinate, pronate, supinate. Okay, so there's a question in your book, and it says name the 2 supinators in the arm. And it was a little confusing in the book, if you ask me, so I put them here for you. The 2 supinators are the biceps brachii and its antagonist, the pronator. So this and this are working to get my arm to pronate. So my biceps brachii, my pronator teres. And my supinator with the pronator, doesn't it make sense that the antagonist of a supinator would be a pronator? Right? Because it's the opposite. So when my supinator contracts to do this, my pronator antagonist, my pronator quadratus has to relax. Yes.
What question did you say that asks 2 supinators?
What? Yeah. What are the 2? What are the 2 supinators
you know
with their
question.
antagonists?
You know what question?
I don't remember what question. Did I write it down? No, I did not write it down. Okay. So, and it may have changed in the new book.
Alright.
Maybe it's a little more clear in the new book. But it definitely was in there, and I had to really kind of pick through in the old book, had to pick through the paragraph to figure out exactly what they were. So I wrote them down for you right here. So remember what I told you about the supinator being a stronger muscle. Therefore, if you need to open a jar, use your left hand. Even right-handed people will have better luck opening a jar with their left hand. Left-handed people are great at opening up jars. So if you're left-handed, you may have people say, hey, could you open this jar for me?
It's really weird, honestly.
It's a stronger muscle, than this. Right?
I
Versus.
expect dominant hand to be a stronger one, but
All my kids open all of the jars with their left hands, even though they're right.
No, I was lifting something in the sink. There was like a bunch of cast iron. I tried to lift it up with my right hand. I was like, dang, that's heavy. And I grabbed it with my left hand.
Because you're probably supinating to do that. Supinate. It's a stronger motion in your arm right there. So of the forearm, I think these are the ones I'm more concerned with, the more interested I am versus all those extrinsic. I really like these. For the extrinsic, I really like these. Pronator teres, pronator quadratus. I'm fascinated with supination pronate. You may have noticed that. That fascinates me. We do that. There's that game. Should be called the supinate pronate game. All right, we good? All right, now you can see them really nice here. Here's our brachioradialis. Remember, brachial arm, radialis down the radius. Okay, then we have our extensor. Look at the purple one. The extensor carpi ulnar going over the ulna. Remember, the ulna hooks up here to the pinky finger. Ulna shorter, right? Then we're going to see our extensor. Where's the green one? Hard to see it. It's in the back, and it comes through right here. The extensor digit minimus. And our extensor digitorum, it's going to extend my digits like that, okay? And then I want you to see around the wrist right here, there's this really important bit of connective tissue that's kind of keeping all those cables in place. If I got a bunch of cables coming, it's kind of like when you have your cords, you have something to keep your cords in one place, right? All right, so our brachioradialis, extensor carpi, ulnaris, I just mentioned all of those. Our extensor carpi, radialis, longus, and brevis, longus being the long one, brevis being the short one. One more, extensor digitorum. If you hear that, extensor digitorum, extend the digits. It's in the arm. That's the back, notice that's posterior. was the ones on this side of the arm. And so that extensor retiniculum is the tissue that's holding everything together there, which we'll get to in a minute. So y'all are using these muscles right now to write notes. You're using intrinsic and extrinsic. Okay, let's talk about our intrinsic hand muscles now. Remember, we can have, the hands are not too bulky because we have so much power coming from outside of our hands. And I want to talk a little bit about finger flexibility. Okay, so if you put your hand down flat and you lift up your fingers, you can lift up your pointer finger, your middle finger, but this little finger you can't, this ring finger can't come quite as far. And it has to do with the tendon for the muscle only runs about up to here versus all the way to the end, right here. Let me show it to you here, okay? And we're gonna see our carpal tunnel syndrome. All right, so in our ring finger, the tendon runs a little shorter, and there, who plays piano? Okay, does it ever bother you that finger isn't as responsive as the other fingers? Have you ever noticed that?
Yes.
Do you know who Robert Schumann was? Robert Schumann was a conductor, he was a composer of music, and he was his compositions have to do with piano. Well, he was very frustrated that ring finger was so hard to manage versus the other fingers being much more manageable. And so he said, I know what I'm doing, I'm gonna work on getting this more flexible. So he ended up tying at night, he tied up his ring finger so it stayed up to stretch it. He ended up ruining it. And he couldn't play piano at all after that. So just be happy with the way God designed it. He just made that finger a little less responsive for flexibility. Don't know why. But you can see how maybe if you have to reach over. I don't know how y'all do that with the piano. I don't know how you do two different things. I don't know how your brain does it. I think that's fascinating. That fascinates me. I kind of feel the same way about the guitar, right? You got to do this and this.
I played flute for a long time, my father and flute too.
It's like
That
muscle memory for guitar. You just keep your hand like this and you just move this.
But what about the people that do? What about banjo? Like banjo.
Yeah.
Fascinates me.
I
You know,
know.
it's crazy stuff. I played the bassoon, so I did have to do some things, but for some reason the piano makes, I think you're
It's
super
like the same
talented.
thing.
I know. I wasn't very good at the bassoon, so. All right, now let's talk about this. When we remember I said there's that big, it's called the flexor retiniculum. We called it something different earlier, didn't we? That's connective tissue bringing all those cables in so they can kind of be contained in this very narrow area called your wrist. Okay, and have you ever heard of carpal tunnel syndrome? So carpal tunnel, so it turns out that carpal, those are carpal bones, there's that hole in which all those things can run. All this stuff can run through there, and sometimes that becomes, because it's a narrow area, becomes inflamed. And we have this thing called carpal tunnel syndrome. Let's watch a little video on it.
Carpal tunnel syndrome is a condition that results when the median nerve is compressed as it passes through the carpal tunnel in the wrist. This compression results in pain, numbness, and tingling in the thumb, index, middle finger, and the adjacent half of the ring finger, since all of these receive sensory and motor function from the median nerve. The pain can potentially also extend up the arm. In addition, the affected person's grip might be weakened, and their dexterity worsened. The carpal tunnel space is defined by the carpal bones and the transverse carpal ligament. Apart from the median nerve, 9 flexor tendons also run through the carpal tunnel, and these allow you to flex your fingers. Compression of the median nerve can occur either because the carpal tunnel decreases in size or because its contents increase in size, for instance, through swelling. Carpal tunnel syndrome typically begins in adulthood, and 1 in 20 people in the US have it. Since women have smaller wrists and smaller carpal tunnels, they are more commonly affected. There is ongoing debate about whether or not carpal tunnel syndrome is caused by repetitive movements and vibrations. There are also conditions that are risk factors for the development of carpal tunnel syndrome. Rheumatoid arthritis is a risk factor since it causes inflammation of the flexor tendons. Pregnancy can cause water retention and hence swelling in the wrist area. Injuries to the wrist can also cause swelling. You can also just be unlucky and be born with a smaller carpal tunnel. Without treatment, up to 1/3 of those who get carpal tunnel syndrome will improve in about a year. For those who don't improve, symptoms can gradually get worse over time. Long-term complications can include permanent nerve damage, and the resulting sensations can be severe enough to wake someone up at night. Another long-term complication is wasting of the muscles at the base of the thumb. Severe carpal tunnel syndrome can be treated surgically. During surgery, the transverse carpal ligament is cut, freeing the median nerve. This surgery is reserved for severe cases, since it makes the carpal bones of the wrist slightly less stable, and it weakens the hand muscles anchored there.
Okay, so I have a friend who had the surgery. I think it would make me nervous to do. I might just wear a wrist brace or something, because it might make me think, oh, they're gonna cut right through the important stuff there. All right, upper leg, posterior, back side, right there. Okay, so we're gonna see gluteus maximus. We all know that one. If you get a shock, usually you'll get it right there in your gluteus maximus. That's your rump. It's the big. It's called maximus because it's so large. Okay. We're gonna see a gluteus medius. That's gonna be in the middle. Can we see it in this picture? I don't think we can see it. It's underneath the gluteus maximus. And we have the gluteus minimus too, all underneath here. Okay, the gluteus minimus actually comes up toward the top right back here, and some shots are given right in there. So those are our glutes, right? Notice this one's called the adductor magnus. Ooh, adductor. What's it? It's going to pull your leg in. The adduct bit. Our hamstring. So the back of our legs right here. You may have had an injury before in your hamstring. Hamstring is a set of 3 muscles that are working together. All right, and we're going to see the one's called the biceps femoris. So remember, biceps brachialis the arm, biceps femoris is the back of your leg. Over the femur bone, biceps, it has 2 heads to it. The semimembranosus, I think we can see that right here, the semimembranosus is coming down this way, and the semitendinosus. Oh, that's the tendinosus right here. The membranosus is right here. So we have this set of 3 muscles that are working together, and they're working together to bring, I believe, to bring the leg back down. Our front muscles are going to bring our leg up, and these are going to bring our leg back down. You've seen somebody on the football field, and you know it when they hurt their hand, they grab the back of their leg, and they're having trouble. It hurts, right? So they pull the muscle in their hamstring, that set of 3 muscles. Good? So the glutes and the hamstring. I'm not sure why it became known as the hamstring, except in a pig, that's where the ham is found, in the leg. So, I don't know. Upper leg anterior, the front of our leg here, our big set of muscles right here is to lift your leg like this. We have a set of muscles called, first of all, our sartorius goes all the way from our back, all the way back here, around like this. Does anybody know what the word sartorial means? You ever, I don't hope this doesn't, if anybody, sitting Indian style, when you cross your legs? It's also called tailor style, like a tailor used to sit that way or something. The sartorius is what is kind of guiding your legs to bow out like that. That's our longest muscle, by the way. The iliacus and psoas major, those are in our front leg there. And what I want you to really key in on is the big muscles in the front called the quadriceps. Just like the hamstring is 3 separate muscles, guess how many muscles are in the quadriceps? 4. Some people say it's 4 different heads. Most people call them 4 separate muscles. We're going to look at it as 4 separate muscles. The rectus femoris, we know where it is. It's over the femur. What else do we know about it? It's straight. Rectus means straight. Do we see that here? Rectus. femoris. I don't know if I see it on that picture. Our vastus lateralis. That's going to be to the side. We've cut away a little bit here. You can see our vastus lateralis is on the side. So which one did they cut away? Oh, that's the rectus femoris that they cut away, the big one. The big one in the front. They cut away so we can see behind it. The vastus intermedius is behind the femoris. And then the vastus medialis. Intermedius and medialis would be toward the middle. Medialis. So lateral, medial, intermedial, below the rectus femoris. So if you can remember vastus, we've got three of them. Lateral, intermedius, medialis. And then rectus femoris, we know it's on the femur, and it's straight. We're getting close, yeah? Like I said, a lot of memorization in this one. Okay, the lower leg, I was talking to you earlier about your calf muscle. When you stand on your tippy toe, your calf muscle kind of, remember our leverage right there? It's called the gastrocnemius. That's a weird word, gastrocnemius. I have no idea where all those words, gastro reminds me of your stomach, so I don't get it at all. And our soleus, right here, is alongside it. All right, notice this gigantic tendon coming down here, holding all that together. Remember, we walk upright. We walk on two legs. It's very rare in the animal kingdom to find creatures that walk on two legs. The way our patella is attached and our Achilles tendon is attached. It attaches that muscle all the way down below our heel. And we know why it's called that, right? Because of Achilles, the hero from the Trojan War. The heel bone is called the calcaneus. The peroneus longus and the peroneus brevis. Just the long one and the short one. The long one and the short one. Look at this tibialis. Do I have that? I don't have that one. Tibialis anterior. Oh, that tells us exactly where it's over the tibia, and it's in the front. Tibialis anterior. How about that? I wonder if that means there's a tibialis posterior. I don't see it. So those are some in the lower leg right there. Notice at the ankle, once again, I also have some of that extrinsic action going on. Our feet aren't nearly as useful as our hands for things, right? We don't have the digits on our toes are not as long and useful as our hands are. Some monkeys can use their toes as well as they can use their hands, right? Not us. Really, we're talking balance here. We're talking the strength to hold us up all day, standing on 2 feet, 2 legs. All right, we have our abductor digiti minimus. That's going to adduct, pull our toes in this way. I can't really think about that. Flexing our toes is going to lift our toes up. Flexor digitorum brevis are short. Coming through here, we can see some of those lots of tendon action here, just like with our wrists. And abductor, we're looking at, when we try to bring our feet in and out like this, that's usually going to be our leg muscles that are doing that, not our intrinsic foot muscles. So where you're going to pigeon toe your feet, that kind of thing, you're going to be using a lot of muscles up here to do that. And where you're going to, ballerinas, what's this called when you put your feet out like that? Some sort of position that's making my feet cramp. Yeah, first, fifth, whatever position. Yeah, that kind of thing. Not as interesting as the hands. That's an opinion. Here you can see those a little closer here. The abductor coming in, the flexor, toes up, and toes, tippy toes. Toes up, toes down. All right. Okay, this is, we got time for this. This is a kind of a long video, and this is a doctor looking at the muscles of a cadaver. Okay, so I hope it doesn't bother anybody. It's not like, it looks like a preserved specimen. It's not disturbing at all. Okay.
Okay, what we have here is a human cadaver. Cadavers are used by medical schools and for training medical students, of course, and also health professionals such as the nursing students we have here. They are donated bodies. The bodies are prepared in such a way that the blood is exsanguinated, removed, and preservative is infused so that as long as the cadaver is kept from drying out, it will be preserved for quite a long time. This one, as you will see, is a little bit dry, but has some very good anatomy nevertheless. What I'm going to be doing is uncovering from the neck on down, and as I do so, I'll be removing skin that was just replaced in order that the cadaver might not dry out quite so much. There we go. Okay, we'll start with the muscles that you see. Now, in terms of dissecting a cadaver, it's fairly tedious work. What you have to do is, again, remove the skin, as you can see, has already been done. And then the fascia that covers the muscle, that's the connective tissue, has to be removed. And in effect, it's pulled away. And a good dissection is judged by how well you can see the fibers of the various muscles. And you can see the direction of fibers quite easily here. So we have a nice dissection of the muscles to work with. I want to name the muscles for you, starting with this obvious one, pectoralis major. Don't forget, every muscle tells you something about its name. For example, pectoralis major is the big one of the chest wall. It's a flexor muscle. It also adducts the arms. When I remove it, and I can do so completely, I see under here a remnant of the pectoralis minor, the small muscle that can lift the ribs as when we take a big inspiration, or it can pull the shoulders down as when we say pull something from above on down. It can do either of those. Here we see pectoralis major. Again, you can see the long skeletal muscle fibers in this direction. Let's go down to the abdominal muscles. These are the dissected rectus abdominis muscles. And if you know what a six-pack stomach is, well, what we have here is those skeletal muscles. They're interrupted by connective tissue, and that gives that appearance where each segment can be contracted. Over here, dissected away, we have the, let me just remove the chest wall here up out of the way. We have the external abdominal oblique, or the external oblique muscle. You can see the fibers coming in this direction. Deep to it, we have the internal abdominis oblique, or internal oblique. And if you look closely, you'll see that the fibers going at right angles to each other. These external muscle fibers in this direction, and these ones in this direction. And deep to this, but not dissected away, is a thin muscle layer, and that would be the transversus abdominis muscle. All three of those preserving the contents of the abdomen in the proper place. Okay, this is the muscle that I bet you would recognize, the biceps brachii. Biceps means two heads. Here we have one head, the tendon to it. Here's the tendon to the second head. Of course, they merge here in the belly of the muscle. This is the insertion, which inserts into the radius and into connective tissue in the forearm. And as I'm sure you know, the biceps muscle is capable of flexing the forearm, as I'm illustrating for you. Posterior to it, what we have here is triceps brachii, and not so easily seen, but it oppositely extends the forearm, and that's very typical. A muscle on one side will do one thing. The muscle on the opposite side will have an opposite action. Down here in the forearm, we can just enjoy the beauty of the forearm. The muscles here have long tendons and attached to the fingers on either the posterior or the anterior side, so that we can say that the hand is a very delicate instrument, but it's strong. It's strong because it's cable operated. The mass of the muscles is in the posterior and anterior forearm. Let's take a look at these. Well, this muscle is sort of a landmark. Let me hold it up for you. This is brachioradialis, beginning in the brachium, going down to the radius. We can see it's tendon here, it actually flexes the forearm. And in the posterior side, again, we can notice those long tendons so that the strength is here, the delicacy is up here. These muscles, tendons, are held down by what is called the extensor retinaculum. It's dense, regular connective tissue that prevents a bowing out of the tendons as we hyperextend the hand. But anyhow, let's take a look here. Right dead center is the extensor digitorum, and it does what its name suggests. It extends the digits. To the side, we have extensor carpi ulnaris, and its name tells you that it extends the wrist on the ulnar side, and that's what it does. When we extend the wrist, of course, we extend the whole hand. Right here we have extensor carpi radialis, which also extends the hand, but it's on the radial side, the thumb side. These two muscles move the thumb. You can see them moving out obliquely towards the thumb that you see here. Okay, well, let's move down to the thigh and the leg and take a look at the muscles that you see here. First, the big quadriceps femoris, which means the four heads of the femoral region. This is rectus femoris. It comes down, and it's got a tendon here that encloses the patella, which is called a sesame bone. It's like a callus that develops in that tendon. And it goes right through, and we can see the insertion on the bump. You can feel this on your own anterior leg right there. That's the insertion. It's called tibial tuberosity. And this muscle, you can imagine pulling on here, it will extend the leg. It also can flex the thigh because it goes clear up to the ilium. This muscle, the very slender muscle that you see here that's been detached, is called the sartorius muscle. Sartorius relates to the word sartorial, splendor, your clothing. It means tailor, and tailor sitting means what I as a child called Indian sit, where you sit with your legs in this more or less position. It does all three of those actions, enables us to tailor sit, and thus the name sartorius. Over here, I can see the adductor muscles, which pull the thighs together, and those are the muscles that ache after a day of horseback riding, unless you do it daily, of course. Thin little muscle here, gracilis. Moving down here, this is actually, while I'm here, I should show you, this interesting vein is the great saphenous vein. In cardiovascular bypass surgery, this vein can be removed and used to replace veins or arteries within the heart. And the deep veins of the legs then will bring the blood from the lower body back to the heart. Just while we're there, we need to mention that. Okay, let's look at the lower leg here. And what we see here is the medial bone, the tibia, and I can see tibialis anterior with its tendon coming down this way. The next muscle would be extensor digitorum, which extends the digits, that is the toes, and peroneus longus, which means long pin.
All right. Muscle injury, if we have a sprain, that's an injury to a ligament. You get that from twisting. A sprain is a pretty bad injury. I sprained my wrist this summer, and boy, howdy, it took a long time for that to heal because it's to a ligament right there. Also, there's swelling and that kind of thing. A strain is injury to the muscle. It means that if you overstretched it while it was contracting. And then a pulled muscle would be a mild to severe tearing of muscle fibers. That's why it's important before you work out or anything to do some stretching, get those muscles ready to be moving so you don't do that. Now, a sprain oftentimes will happen from a fall. That's what happened to me. I had fallen and boom, I'm glad I didn't break anything, but it was definitely a sprain. All right, and here we're going to watch this real quick about how the muscles grow.
Muscles. We have over 600 of them. They make up between 1/3 and 1/2 of our body weight. And along with connective tissue, they bind us together, hold us up, and help us move. And whether or not bodybuilding is your hobby, muscles need your constant attention because the way you treat them on a daily basis determines whether they will wither or grow. Say you're standing in front of a door, ready to pull it open. Your brain and muscles are perfectly poised to help you achieve this goal. First, your brain sends a signal to motor neurons inside your arm. When they receive this message, they fire, causing muscles to contract and relax, which pull on the bones in your arm and generate the needed movement. The bigger the challenge becomes, the bigger the brain's signal grows, and the more motor units it rallies to help you achieve your task. But what if the door is made of solid iron? At this point, your arm muscles alone won't be able to generate enough tension to pull it open, so your brain appeals to other muscles for help. You plant your feet, tighten your belly, and tense your back, generating enough force to yank it open. Your nervous system has just leveraged the resources you already have, other muscles, to meet the demand. While all this is happening, your muscle fibers undergo another kind of cellular change. As you expose them to stress, they experience microscopic damage, which in this context is a good thing. In response, the injured cells release inflammatory molecules called cytokines that activate the immune system to repair the injury. This is when the muscle building magic happens. The greater the damage to the muscle tissue, the more your body will need to repair itself. The resulting cycle of damage and repair eventually makes muscles bigger and stronger as they adapt to progressively greater demands. Since our bodies have already adapted to most everyday activities, those generally don't produce enough stress to stimulate new muscle growth. So to build new muscle, a process called hypertrophy, our cells need to be exposed to higher workloads than they are used to. In fact, if you don't continuously expose your muscles to some resistance, they will shrink, a process known as muscular atrophy. In contrast, exposing the muscle to a high degree of tension, especially while the muscle is lengthening, also called an eccentric contraction, generates effective conditions for new growth. However, muscles rely on more than just activity to grow. Without proper nutrition, hormones, and rest, your body would never be able to repair damaged muscle fibers. Protein in our diet preserves muscle mass by providing the building blocks for new tissue in the form of amino acids. Adequate protein intake, along with naturally occurring hormones like insulin-like growth factor and testosterone, help shift the body into a state where tissue is repaired and grown. This vital repair process mainly occurs when we're resting, especially at night while sleeping. Gender and age affect this repair mechanism, which is why young men with more testosterone have a leg up in the muscle building game. Genetic factors also play a role in one's ability to grow muscle. Some people have more robust immune reactions to muscle damage and are better able to repair and replace damaged muscle fibers, increasing their muscle building potential. The body responds to the demands you place on it. If you tear your muscles up, eat right, rest, and repeat, you'll create the conditions to make your muscles as big and strong as possible. It is with muscles as it is with life. Meaningful growth requires challenge and stress.
Alright, so that is it, y'all. What I'm going to encourage you to do for getting ready for next week is maybe make flashcards to remember the names of things, you know, and maybe have upper arm, lower arm, that kind of thing in there. Alright? And we'll have a fun lab next time. So I will see y'all then.